Yeah, I saw that you wrote coefficients because somebody, I don't know. Somebody was writing and then typed coefficients.
That's because I didn't have a lot of trouble making boxes. Every time we tried to make a box, it like birthed a twin, and we had to throw the box.
Is that why there's random? I was wondering about that.
Yeah.
Okay, so now realize what you wrote here is less than 1.
Okay.
Did you mean greater than 1, more than 1?
So, it's more than one possibility.
Yeah, but this is less than 1.
Yeah.
So these are backwards. So assuming that now, why are these not more than 1?
There's only one possibility.
Because they don't all have a common factor.
Yeah, they involve prime values, right? So the prime values don't involve common factors. So today, to leap over the rest of this, because it should have all been pretty similar. And we should have heard about closed before. What makes a set closed, right? Integers are closed under addition and subtraction and multiplication, but not division, right? Integers, when you divide integers, you won't necessarily get an integer out. So when we investigated this, what did we come up with?
Oh, we didn't finish that.
Well, I just told you for B.
Put a square on it.
And what about C? Anytime you multiply integers, do they come out to be integers?
Yes.
Yeah, but not division, right? So that's how we check closed, look for where it breaks down. So today we're looking at what's called special quadratics, just like how we are all very special, as Mom told me the whole time I was growing up. Such an 8th grade attitude.
You know what we're talking about? I was saying, like, if I had my donut, and, if I had a child, and if I dropped my donut, I would have whipped it.
All right, so we are going to go through these special cases 3 at a time. And I want you guys working together because I kind of want to see how that looked yesterday. When you think you agree on the factored form of all 3 of these, check your answers with me, and then we will move on to the next set and potentially a different challenge. What? Sure, but you also need to write it on your paper, so if you're using board, make sure you get it copied over there at some point.
I need graph paper, so that might be helpful.
Pens live there.
Right here. Pins
Literally, pens have been living there for like months.
Wait.
Yes, because I don't like, 1, I don't like how hot it stays in the Yeti, and 2, I don't like the taste of things when you drink out of metal.
Oh, yeah.
Oh, yeah.
I'm very particular, and if I'm going to drink coffee every morning for the rest of my life, I'm going to do it how I want to.
Okay.
My brother-in-law is so particular, he does like a Chemex pour-over thing. Hey, you guys are trying way too hard. So first off, that menu should not be up. So this button pulls it up and deletes it. So it's over here normally. But if you swipe from the left side of the screen, it'll bring the menu in. So if you are on one of these tools, you can't just keep making another one. You're on the tool. If you want to edit, and everyone should be paying attention when you guys use, when you want to edit something you already have, literally just throw it somewhere else. But if it bounces, yeah, it'll bounce back down. Because you can't throw it off the edge. Now you could also just make a box manual.
Yeah, but he doesn't like it.
That's how we created like 5
We
million
have
little
like
boxes.
any
Metallic
for
shirt.
this?
Oh, chargers? Yeah.
Yeah.
I always have a charger plugged in
I
over
don't
here.
know where mine went. I thought it was in the locker, but it's not. So.
Here, come here. I got you. I can't like move it though because it's all plugged into everything.
It's not. It has some battery.
No, we might as well charge it. If you leave it charging while you guys go to lunch, it'll be fully charged.
Okay. See, I have to use. I just use the same charger for those as I do for my phone. So I mean, if I lose, if
Your phone takes an old version of USB then. That's an old USB charger, like the computer weird trapezoidal one. I don't think many phones take that. Are you sure about what
She
you're
might have a
saying?
different calculator.
We're missing. Wait, are we missing the B value in that?
Ah, we are missing the B value. Now, we talked about this really, really briefly the other day, like last week, because yesterday I wasn't here.
Yeah, you know what I should do? I should put this with the calculator so I don't lose this too.
And so that means at the bottom should be 0, right?
7 is
Wait,
it?
should it? Like, at the bottom for the diamond should be 0.
Okay, I should start writing things down.
Oh, it would be 7.
Oh, it's the thing where they're. I can't remember what it's called.
I've been doing this my whole life. I shouldn't spell it wrong. Yeah.
Whenever I type my name, I always spell it S-O-H-I-P.
Wait a second, did I do something? No, wait, what did you get?
Like, no, that's not right.
No,
No,
okay. You put negative 7 spaces up here. What?
We can clone pages too if you just want to do one per page or something like that.
Or you can extend
So with the B value missing, as we talked about the other day.
It's the thing where it's like the one's positive, one's negative.
Yeah, now there's a specific name for that too.
Yeah, I was trying to think of that. And it's left my brain.
We will remind ourselves of that name here later.
So the answer is x minus 7x plus 7, right?
Oh, by the way, what we did yesterday was have some people out there doing.
Liang, sit down. Yep, you lost your opportunity now because you're just playing with bouncing boxes.
Okay, I'm gonna move
That's twin number like 5 now, right?
move that over there.
So A, if you're dying to know what it is, which I don't think any of us are, is a difference of squares, is what we call that, where the B value is missing.
Okay.
Because 49 is a perfect square, except for the fact that it's negative, which is why we call it a difference of squares. So now, yeah, we always fill in those diagonal first.
So, and then X. So, I feel like I should. That's what I thought, but then I was doing -4, like, -4 and 6, right?
Yeah.
Because, yeah.
Yeah, you are correct.
I did it too close. I'm just trying to do it up here. Wait. I don't know if that would.
By the end of the year, you guys will at least know how to work the smart screen.
What?
Your handwriting needs to improve, though.
Yeah.
How did you learn so quickly?
Because you guys did it.
It's my job.
What do you like? What was the first few days?
I don't know.
Hey, why do you need to disconnect it? Is there a reason that you're trying to fight to move that? You can write the factors somewhere else. We can see it. Hey, you can put the factors on the left and the top. Or the top and the, like, you can put them anywhere.
Like, it doesn't have to be.
Yeah, it doesn't have to be left and bottom.
Mr. Hudson, I have a question for you. So, why do you prefer the, like, squared X value on the bottom rather than the top?
Oh, it doesn't matter.
6.
Because that's how CPM sets it up.
'Cause I
You
would
just have to
prefer-
have the...
I prefer it on the top, so then it's, like, already, like, X plus.
That's fine. So you just have to have the x squared value and the constant value diagonal from each other. That's the only thing.
I put them on the top.
Yeah, if you want to set it up different, that is totally fine as long as it still works. Perfect. C. Anyone notice anything interesting about C? When we look at the B value compared to the C value? They're related by a factor of 5. Okay. Well, go ahead. I'm just making you think before we dive into it.
Mr. Hudson was talking about it, so how do you factor it? He said something about it.
But then you'll have 1/5 X, and that's like.
All of these are special in a way.
They're all special.
You're special. Like my mom said so that I'm special. Yeah, and so it's -5x and -5x, right?
Yeah.
-5x and
It's 5.5.
Oh, this is isn't it a square?
You're gonna set this up your way. Make sure we all.
Yeah. I'm gonna set this up my way.
Right
now.
Are you kidding me, Athena?
Pretend it's a perfect square.
Athena, beauty is
Not bad.
What? Oh, well, you could say that.
Yeah. What else would I say?
Oh, I would just
Do we remember what this is called?
A perfect square.
A perfect square
Oh my gosh.
trinomial.
Square.
All right, so let's try this again. See if we can speed up a little bit.
I
Ah.
didn't write it down.
We're not doing it.
Yeah, we are.
Can I write the rest of it down?
Hmm? Oh, sorry.
Thanks.
I went back and I didn't. Most of the pages I try to make it so you don't have to scroll. Anytime you recognize that the b value is 2 times the value, and the c value is the square of that value, that should set off bells and whistles in your head that it is a perfect square trinomial.
Okay, I'm done.
So if we look at D, we got 9 and 12, which immediately might think your brain, or might make your brain think 3. And then we look at 4 and we're like, crap. So try that on your own before anybody comes up. Try D, E, and F. Take just a couple minutes. What do you recognize about F?
It's missing.
Difference of squares, right?
No,
It is
X
missing its
has
B.
a
It's a difference of squares.
Wait, what?
F
Oh,
is missing the B though.
Sorry.
So try D, E, and F on your own. Make sure you write the original trinomial first. Now, if you don't have to go through the diamond and the area model, you don't have to.
What?
If you can, like, F, you might be able to figure out just on your own. Because we've looked at what happens with the perfect square trinomial. Makes you feel better. Oh,
I
that's
know
fine.
it's right.
I couldn't quite tell what you were saying makes you feel better.
Okay.
Ice cream makes me feel better.
Yeah.
Are we individually ready? Because if someone's going to the board, I want it to be somebody new.
Oh no.
Or me and somebody new talk it out. In D, is there a common factor that can be pulled out? No, right?
Oh, by the way, I'm just not done, but you can go on if you want.
Are we done with D?
Yes.
No.
Wait,
I'm done with D.
I'm done. I'm done. I'm doing F.
I don't think you can do it.
What? Who said that?
I don't think you can do, he says.
True.
Yeah, because 5 and 4 don't really have a common factor. I mean, like, you can't.
It's negative 5 though.
Yeah, but
And negative
Yeah.
5 and negative.
you can, I can't think that works.
Wait,
Yeah, they do.
how? With what numbers?
So
All right, hold on. Before we dive into E, let's let's get through D if D works nicer. Got all this set up. Two terms that add to 12 multiplied with... Oh, 6 and 6. Oh.
Okay.
Okay. So we have 6x and 6x. Oh, a 3x would be common.
So you could say 3x plus 2 squared. Right? Could you say that?
Interesting. So wait, this ends up being a perfect square,
What fascination?
but the C value isn't the square of half the B value.
I mean, but I don't know if this is a thing, but like I feel like they all use 3 to get something. Like, I don't know how to say this.
Right?
I don't know how to say this.
It's not an exception. It's still applying the rule. We just didn't have every detail of the
Because
rule.
4 is a factor of 12 still. It's not a factor of 9.
Man, I'll make this, I'll even give you just like $1 of straight up money if you can tell me what happened here.
Straight up money.
Straight up money. Like,
Where is the principal?
That rule works.
how is this a perfect square the same way that our perfect square on the last screen was?
Because they all have a factor of
1.
I think.
The
No,
values
four doesn't.
that you're multiplying together.
Because they all have are equal. Like 8 times 8
Like, how could we recognize that before we even jump into the, like, how could we avoid, essentially what I'm saying is I don't want to do this. I'm going to be able to look at it and be like, oh, yeah.
What?
This
Wait a
9
second.
You can't all talk at the same time, so
So
here's
I
time
think
to talk.
maybe like if like the A and B value have a common factor and the
Good morning, George Minister. Please come to the office. George Minister, please come to the office. Thank you.
We're
B and C values have a common factor.
we're potentially going to let this just hang out here for a minute. Liang, and then we're going to
Is
just,
it because like 9 divided by 3 is 4 and then 4 times...
wait, 9 divided by 3 is 4?
I mean, 9 divided by 3 is 3. And then you take that 3 and then you multiply with 4 and you get 12.
That is not why, but I like that I like that you recognize that. That's just kind of a coincidence here. Let's look at E. We had some skepticism that E may not be possible.
That's not true.
I think
I
E
already
is
did
possible.
E.
Yeah, I think E is possible.
E is possible, so we're rescinding the fact that E was potentially not possible.
What'd you get for 5 then? How'd you
E
get
is definitely possible.
It's negative
I
5
did it.
Liang.
how'd you
So
get
negative
4
5x squared,
And negative 4.
negative
So
4x.
you put
Oh, like a negative 5 and a positive
You
1,
put
right?
negative x and negative 1x. Okay. 5 or that. Sure, I did the
It makes-
opposite of that.
It's, yeah, that's the same thing.
The same
Right.
thing.
I find it
I always
simpler
forget
and
about the
easier
one.
just to put like the 1 there, so it's easier just to look at the coefficients than remembering that x.
Coolio, we're done with yo. Okay, let's move on to the last one.
So probably a 5 here, probably meaning a negative 1 there. So wait,
Yeah.
is this one special?
Yeah.
Like perfect square or
No.
differences?
And
So it's like
one
x.
is-
red? It's red.
So it's x minus 1,
It's average. No one likes average.
5x plus 1.
It's
But it
okay.
is possible, right?
My mommy says average people are I wonder why.
At some point, you get mature enough that you don't have to constantly talk.
I'm sorry.
4x squared minus 25.
You don't need to do the perfect square root. You can just the square root of 4 and the square root of 5.
Okay, so it's, you're saying it's 2x.
Wait, how did you get that?
2x plus 5 and then times the sum of 2x minus 5. Because it's, you know, it's a difference of squares because there's no b value.
When the C is negative
Yes.
and the B is gone.
Okay.
This is a difference of squares. Now, the trap door people try to fall in is doing something like this, but negative 5 squared is positive 25, And then we would have a 10x, sorry, a negative 20x in the middle. And we don't. Right? Because if we wrote this is wrong. Sorry, I have it written up here, but this is wrong. Because the positive here and the negative here cancel out the b value. Okay. Right? So when the c is negative and we're missing a b. Now this brings up the question, what if the c is positive and we're missing a b?
Wait, hold on, wait. So if the c is negative and
we're missing a b?
Wait, if the c value is negative...
Don't answer before you get to think. If the c is negative and there's no b, it's a perfect, well, look for, is it a perfect square, right? Or not perfect square, difference of squares. So for example, if you want to make up another one, actually let me check. So here, right? The a is a perfect square value because 1 is a perfect square. The 36 is a perfect square value, but it's negative. So skipping g for a moment, if we look at the fact that this is negative, there is no b, so take the square root here, and that's going to tell us what your constant is. Take the square root here, which on our last slide was 2, right, because square root of 4. And then we have to do the same thing, just plus instead of minus.
So the difference of squares is really simple.
Because then our, remember FOIL, first gives me the x squared. Outer and inner cancel. That's why it's difference of squares. This would be positive 6x, and this would be negative 6x. And then the last gives me the negative 36. If we go back to that old school technique of FOIL. All right, so let's do G and I on your own real quick.
Is this what the homework's gonna be like? With like a...
Wait, I hope so.
Why do you hope not?
You see, the thing with G is that they take up a lot of space, and it's just...
Is I supposed to be 72x and I...
Sorry, it's supposed to be 7x squared.
Oh.
I don't know why that square got goofed up in the formatting. That's 7x squared minus 20 minus 3.
It's actually an unknown number. You have to figure out the 10th digit.
So what you recognized right?
B divided by 2 squared equals C. Let's see. You're right. Yeah, that's right. Oh, and
No, that doesn't work.
Wait a second.
Wait, what?
B divided by 2
Yeah.
squared. It doesn't work here.
Wait a second.
No, wait. But 12 divided by 2 is 6. To the second is 36.
That ain't 4.
But it is 36. Oh, it equals C times A. Or wait.
That is not.
Yeah, wait.
B doesn't equal C times A.
What's your A here? 1. So the thing I'm not going to tell you today that is at play somewhere in here
Wait, so is that false?
is the A value. No, this is true here, but A is related in here somewhere, but it's a 1, so it doesn't impact anything.
Oh.
We're not going to formalize this today. I'm just making you think, pushing your brains. But when we see this, we can guess pretty well, especially if this is a 1, that it's going to be perfect square, right? Because this is x minus 3 squared. Now, hold on. If there was an A, Let's say A was like 4.
A was 4.
Still, B divided by 2 squared equals C.
Well, yeah.
But my binomial down here just has to do... Ah, crap, this won't work.
Wait.
Because even if I try to make this 2x, that will then give me, in the middle, a negative... Instead of 6, be negative 12x.
So if we do 4x, then it turns into kind of like the other, like D was 9x squared plus 12x plus 4.
Just let that thought marinate back in there. We'll formalize that eventually.
I'll probably forget it by the time lunch is over.
Is this a perfect square? That's negative. Yes, we already talked about it. Good, move on. And 7x squared minus 20x minus 3. So in the old school method that Mr. Smith and I were talking about earlier, what we would know for sure is we need a +1 and a -3 or a -1 and a +3. So we would actually set up a few options and say, these have to be true, one of these, to make the -3, right? Because when you think through FOIL, this comes from your last. So either boom, boom, or boom, boom, make that happen. But we're not living back in 2005 when I learned this in high school, literally. God, that sounds like a long time ago. Since we're not in 2005 in Mr. McCulley's class, much love though, we use our method and say -21x squared.
And then -20x.
-20x. What about me?
You were in high school before we were
I graduated high school in 2007.
Yeah, and
So you graduated?
Yeah, I graduated
You're like
college.
1.
I graduated college in 2011.
we were like in element.
Yeah.
Did you think when we were in elementary school that we'd ever meet up with him?
No.
Did I ever think when I was in college that I would teach humans that were then babies? No.
Right?
Like, it's weird to think about. I wouldn't have gone to somebody on the street and be like, that child might be my student someday. Like, that's weird, right? Like,
No, but I think that's something David would do, though.
okay, we've got this, but I need to add up to -20.
-21x and then
So you need a negative and a positive.
But that'll multiply.
You need a negative and a positive.
Oh wait, you said -21 and 1, like a positive 1? That would work here, so let's check out if it'll work in the boxes. So 7x squared, -21 doesn't really matter where you put it, because they're interchangeable, remember? So which one gets the what? Yeah, which one gets the what? 7x should probably go the direction of your 21.
It's supposed to be
Oh.
it's not it's yeah.
There are still opportunities for mistake, even taking this method, which is better. I goofed. I actually wrote 20 instead of the 1x. So 7, this then would be
Oh, by the
1,
way, the
I'm
other
guessing.
one would be -3. If you want to fill in the box. And so x minus 3 times 7x plus. My one does not look like a
So guys, I was trying to convince my 7th graders about using the area model and how they're going to use it in high school, and like I showed them our notes. And what I want to reiterate is, like, this seems like it takes a fair amount of effort, but the old method of doing it was 8 options, at least a minimum of 8 potential options,
So this one's much better.
and only one of them is right.
So then who
right? So when I brought this up to Mr. Smith, he was like, yeah, it took so long. Because you would just set up the have to in the binomials, like the +1, -3, or the -1, like, and then you'd try out all options.
So it's basically kind of like guess and check.
Yes, it was guess and check with FOIL. You would just check, does the FOIL come out correctly? I don't know who formalized this method, but it is a I know it is a CPM thing.
Good job.
I don't know if
whoever did
CPM
that, because
I don't know if
that's
CPM
big.
formalized it or if somebody else did and they piggybacked on it. All right,
Or
so
teachers, I'm not teaching. I'm sorry.
try these. Let's see if we can speed up.
There's
Oh,
more.
what the heck? Like the letters are getting annoying.
J K L.
There's like
This is
gonna
like,
be a,
guys, you only have one question.
and it's like
Look,
goes
you
to
say
B.
J.
And then it goes to
We
negative
only have
A,
one.
negative B.
We only have one problem, but it has
So,
right there.
hey, let me help you appreciate what we're doing now.
Are they
If
gonna
we
start
were
going
doing the
to
old school method, our options for here and here could be 2x and 2x, 1x and 4x, or 4x and 1x.
Oh boy.
Right? Like, so to start, there are 3 options for just what could go in those
And if
places.
it's like there's
Wait,
like
I
the bigger
have,
the
like-
number, the more you could like.
Wait, I have a feeling this is like a perfect.
Then we would have to check,
Huh.
do the outer and the inner make the B? And then verify that it works for the C.
And then if it doesn't,
Somebody cut off my hand right now. Like, I don't want to do that ever again. Just like I don't really ever want to standard algorithm multiply ever again. So instead, use our strategy. 100x squared. Do I make you use blow charts?
No, and I'm glad.
That's because I try to be nice.
Oh, you're 16.
And it doesn't make sense
I
to
was
use
right.
something you don't agree with. Like,
I think I'm right.
It takes 2 minutes.
gotta multiply to 100x
This is
squared.
also a perfect square.
Oh, hey, 10 and 10.
Yeah.
Wait, okay, I feel like there's like a similarity with all of these things.
we don't have numbers and X's.
Yeah.
I mean, 25 is a perfect square, right?
The majority
It's
of them
like-
follow
it was
like
like-
the standard form
It was like,
of the.
it was like 9, 12, 4, 4, 20, 25. They all have like 4 times 5 equals 25 times 5.
And if I just straight up told you right now what the trick is, it won't stick. You won't, because you won't discover it. There is something peculiar happening here, and we can formalize it as a rule. I'm not giving it to you though.
Wait, so I have to figure
It's
out by
looking.
myself.
If you want to figure out that little like trick / rule, whatever you want to call it.
Wait, so you'll never tell us?
I'm not saying that.
We'll
Well,
figure it out
today-
eventually.
Today I'm not telling you. So are we doing 4x and 1x or 2x and 2x? It does.
2x and 2x.
Sure.
Because then it's a perfect square. Right?
So then, if I do 5 and 5, we get 10x and 10x. Like what I was shooting
I
for.
figured something out. Is it because the B value has factors of A and C?
What?
Because like it has the factor of 4 and 5.
Five.
And 25. And then like
Is that?
multiply them together.
He's smiling weirdly.
I'm probably wrong.
No, not you, him. It's like,
It's a good guess.
is it a good guess?
Wait, can I see the other ones? Because it might not.
Oh my gosh.
The square.
That's what I said earlier.
B squared minus 4ac over 3a.
Wait, this
There's
one.
something going on. There's definitely something going on.
The second one is also a perfect square. Wait, is a perfect square be like? Yeah.
I'm surprised you have that.
Broken that table yet? Thanks for making me self-conscious.
Yeah.
She's just breaking the table because the table's bad.
It goes like.
Is this perfect square?
It goes like almost.
No.
No,
There's no B.
Oh shit. Me be smart.
Wouldn't it be?
Okay, so since there's no B, we said it's like x plus 2x minus 2, right?
But it's
Yeah.
not.
But it's not that because it's plus.
It's not. Yeah.
It is. That's right. No,
Not
because
bad.
B is 0. No, so you have a
Yeah, but it's not a negative C. Look again.
If
It's not a
if this is factorable, what does that tell us? What do the factors inform us of? If we start with the parent parabola, it's not perfect. But if this was x squared, quote unquote, I don't think there's a parabola tool, although I should write them and tell them that's what they really need. Oh, snap.
He said snap.
I got it.
Now this isn't, it's not, I don't think it's a perfect parabola.
No,
Not
but
that. I
like,
have something else.
it's still better than your.
So I do this and I get that. So it's the same x.
What do you mean it's the same?
Okay, so if you plug it into the
Is it
formula,
like?
the x-intercepts are the same.
What?
Are they real though?
Yes.
Are they real? Oh boy.
You plugged in x squared plus 4 and you got zeros. This is x squared. What does the plus 4 do?
It's the how high or low it is, so it's like
Yeah.
4 up.
Yeah.
Because I am very.
That's what you said. Something like that.
Does this parabola cross the x-axis?
No.
Wait a minute.
Wait a minute.
Wait a minute.
Liang is
I
correct.
don't know what I did. The calculator's broken.
Did you write that program?
I got it off the internet and it's working.
Internet lie.
Here's the crux.
What's the crux?
The crux is the hardest part of a climbing route. Or the hardest part of anything. Actually, if somebody says the crux of this problem, it means like the thing you're stuck on, the hardest part.
Math facts.
There are zeros here. However, they are imaginary.
Oh boy.
Oh, no.
So hold on, I'm gonna blow your mind right before you leave, just to always leave you wanting more.
So
Wait a
You can start packing up if you want.
imaginary numbers.
Wait, hold on. What's the imaginary
Our missed function and get a nice parabola. Now, let's say we want to figure out where the equation equals 0. We want to find the roots. On our plot, this should be where the function crosses the x-axis. As we can see, our parabola actually never crosses the x-axis. So according to our plot, there are no solutions to the equation x squared plus 1 is equal